So I have some good news. There are many, many examples where efforts to save the Bay actually mitigate the impacts of climate change. Wetlands, for instance, sequester carbon at a magnificent rate. I believe maybe even stronger than trees, more rigorously than trees. Oysters growing in reefs can protect shorelines. Maybe there's another blue planet forum in our future. But enough of this, enough from me. We are here to hear an absolutely superb panel of experts teach us about global climate change and answer our questions. The speakers have all asked me to be very brief in describing their biographies. They say, let's leave the time to the program and to allowing the audience to ask questions. They said, just give our titles. I'm not going to do that. Let me tell you just a little bit about them. First, we're going to hear from Dr. Don Boesch on my far right. Arguably the preeminent estuarine scientist in the world and clearly an expert on climate change. Don is the president of the University of Maryland Center for Environmental Science, also proud that he's on the Chesapeake Bay Foundation's board, also the Chesapeake Research Consortium, the Consortium of Ocean Leadership, the Town Creek Foundation Board, and that's just naming a few. Don was also asked by President Obama to serve on a very small group that spent about a year of their life studying the oil spill in the Gulf, the President's Gulf Oil Spill Commission. Next to Don is Dr. Beth McGee, who will discuss the ecological effects of climate change on the Bay. Dr. McGee is a senior scientist for the Chesapeake Bay Foundation and is the Director of Science and Agricultural Policy for us. She earned her Ph.D. from the University of Maryland, College Park in Marine, Estuarine, and Environmental Science. Following Dr. McGee, Dan Berger, to my left, will speak on lessons for the resiliency and adaptation from the South Carolina coast. Mr. Berger is currently the Director of Coastal Resilience Division for the South Carolina Department of Health and Environmental Control. Before that, he was the Director of their program Director for their Program Administration and Communications Division, as well as their Public Information and Technical Resources Division. And finally, before we get to questions, Dale Morris will discuss how we can coexist with nature and adapt to climate change, incorporating lessons from the Dutch dialogues and the Netherlands. Mr. Morris is a senior economist for the Royal Netherlands Embassy. He directs the Dutch government's water management network in Louisiana, Florida, California, New York, and Virginia. He's a co-director of Dutch Dialogues, member of various water management advisory boards and steering committees in New Orleans and Washington. So, let's get on with it. To lead us off, Dr. Don Boesch. Don, take it away.
Great. Well, it's a pleasure to be here, and I see so many folks out tonight. It's a double pleasure because Hampton Roads area has a special place in my heart. I started my scientific career in research on Hampton Roads itself and the Elizabeth River. And occasionally when I was in the Elizabeth River, I used to come up into this little slip area in Ghent, that's pictured here. So I went back there today. This picture wasn't today, but it basically illustrates the problem in a graphic way. So what I want to do is to set the stage for the other discussions, is to obviously in this area so many people are focused on sea level rise, is to show you the evidence about why we know the world is warming, why we know it's primarily caused by human activities, why we know that it's causing sea level rise and therefore more recurrent flooding at higher levels, and what it might mean for the future. So you've probably seen much in the news lately of concerns about the position of the new administration in Washington. In fact, the new administrator of the Environmental Protection Agency said this in a recent interview: "I wouldn't agree that carbon dioxide is a primary contributor to global warming that we see. We don't know yet. We need to continue the debate and review and analysis." Well, sure, we need to review and analyze, but we do know with a high level of certainty that it is human-caused, and CO2 is the largest component of that cause. So here is one line of evidence. So if we take the green curve, the green envelope that you see here at the bottom, needs to be turned on. Yeah, here you go. Here, and we take only the natural factors, mainly due to sun and changing the intensity of the sun, which we can measure. Also, the other natural factor that affects temperature of the Earth is volcanoes. Actually has an effect of cooling the Earth a bit. So we put those into the equation and run the models. You can see that it doesn't explain. This is the solid line is the temperature record for global mean temperature. It's not natural factors. It can't be natural factors alone. If we bring in human factors, mostly greenhouse gas warming influence, and add that to the natural factors, you can see we can predict very well. So we know with a high level of confidence that the only way the Earth should be warming, as we've observed here, is because of these human activities factors. So how much of this warming is due to human activities? He said, Mr. Pruitt said, we don't really know. But we do know. And the answer is approximately all of it. All of it. In fact, if you look at this chart, you'll see that if we look at the observed warming here, this is a range of statistical variation. We look at the effect of the greenhouse gases. Actually, we should be warming more than that, but we're also doing other things, like we're putting up particles and aerosols into the atmosphere, which have, like volcanoes, a shading effect. So we add those two together. You can see we describe very well the combined human forcing functions that match the observed. And if you look at the natural forcings are like, the human factors are like 170 times more potent, powerful to explain the warming than natural factors. So we know this with a great degree of certainty. In fact, if you look at the statistical distribution of these estimations, the answer is it's causing 110% of the warming on the mean, on the average. This is this curve here. And certainly, the probability that it could be causing less than, could be causing more than less than 80% is very small. So we know this with great certainty. It's no surprise. We've known for over a century and a half about the greenhouse gas effect. Scientists discovered it, published it, we've known it. In fact, it's been about 120 years ago that a Swedish scientist named Arrhenius predicted that if we continue to emit carbon dioxide, the world will warm. And he actually calculated the amount of warming we would have if we double the CO2 concentration. His predictions are still remarkably accurate on basic principles of physics. What he didn't know is that it happened much faster than he thought it would happen, because he never imagined that we'd be increasing the CO2 concentrations this rapidly. So here, just from a few days ago, at the observatory on the Big Island of Hawaii, which is selected because it's away from, continental sources of CO2, you can see this sawtooth pattern as the Earth basically breathes. It goes down in the summer as plants take CO2 out of the atmosphere. It goes up in the winter. But the trend is unmistakably and unrelentingly on this trend. This represents about a 44% increase over what it was late in the 1900s, at the beginning of the Industrial Revolution. And it is a concentration that we're quite confident now Earth has not seen in at least 4 million years. So this is not, people say this is, well, it's a trace gas and it's not much. We have really changed this atmosphere of our Earth in very important ways. Now, CO2 isn't the only greenhouse gas which humans are emitting. Others important include methane. A lot of it derived from animal agriculture, but also a great degree of concern now as we use more natural gas, which is mostly made of methane. Leakage, so on, contributes to that. Nitrous oxide, which is produced because we use so much fixed nitrogen for fertilizer. Some of that nitrogen is partially, a small percentage of that nitrogen forms through microbial processes. Nitrous oxide, anyone knows what nitrous oxide is? Laughing gas, if you've had it in the dentist. It's a potent greenhouse gas. So the combination of these three, and chlorofluorocarbons are another one. So the combination of those are causing 75% of the factor is CO2. So, Mr. Pruitt, you're wrong. The science shows that that statement was incorrect. If you don't like that evidence for sure, look at this. Now, we have on this Earth this very thin veneer of an atmosphere. This is the part that's warming. Above that is the stratosphere, where density of gases are very light, very low. So as we have seen the Earth and the troposphere, this is the near Earth, warming, we see the bottom part of the stratosphere cooling. If it were the sun, that would be warming. If it's a greenhouse gas effect, that is, that it's trapping like a blanket the heat in this layer, not letting it escape to this layer, we should see cooling. We see cooling. Another thing you'll hear is that, well, we can't believe the scientists in terms of predictions about the future because all you have is models. And these models are not predicting the warming that we've observed. Again, wrong. Here is the range of model estimates that we've had going from the past, back into the past and into the future. And this is the temperature record, multiple different data sets contributing to the global mean temperature. And we'll see we're pretty much right on target where the models would predict. So the physicist Neil deGrasse Tyson talks about this as of a man or a person walking a dog, and the dog on a leash, and the dog goes like this and like this, but you know where you're walking. You have a good idea in the direction you're walking. The dog, of course, is going back and forth, and that's exactly what we're seeing here in the temperature record because of the natural variable factors. The global warming, in some way, is really ocean warming because most of the heat that's being built up on the planet is being built up in the ocean. Here, this shows you the heat content of the surface of the Earth and how that's changed over recent times, only since the 70s. And you can see most of it's going to the ocean. In fact, it's getting deeper and deeper in the ocean. Very little of it is because the heat is built up in the atmosphere or by melting of ice. So as we'll see, and Beth McGee is going to talk about this, no surprise, our bay is warming. We have records at VIMS, where Mark Lukenbach is, in one of my laboratories, that have been taken, in our case, since the 30s, and we see at the end of the piers this record of warming. Now, surely there's a lot of variation, year-to-year variation, but the trend is pretty robust. It's about 3 degrees Fahrenheit. The average temperature of the bay has increased during, in less than 100 years. So as we think about the future, the question is, how much will the Earth warm? And the first answer that you need to give is depends on us. Because here are two scenarios. These are models that forecast the future. And this is one is if we don't do anything about reducing our emissions. We let them continue to grow till later this century and then figure out what we're going to do about it. And this is one in which we take action now to reduce emissions so that we can constrain the amount of global warming to 2 degrees Celsius global mean temperature. And you can see that we can stabilize the temperature of the Earth and keep it below 2 degrees C. It is perfectly feasible. In fact, this is the basis of the Paris Agreement that was done about a year and a half ago, concluded about a year and a half ago. Reduce emissions to keep warming below 2 degrees C. This is the unconstrained, so we're looking at about a 7-degree or so Fahrenheit increase in global mean temperature. It doesn't sound like much for any given day, but averaged overall, it's a big, huge change in our world. So the basis of the global community, the scientific community's assessment, and then the political analysis to keep our temperature below 2 degrees C is based upon this. So here you see a number of factors, of changes. The most sensitive one, and one that we're very concerned about now, even with the present levels, is the loss of biodiversity, extinction of species. And you can see others, extreme weather events and so on. So you see, as we get to 2 degrees C, things start to get bad. That's why we want to keep it below 2 degrees C. In fact, the Paris Agreement said we should definitely keep warming below 2 degrees C, but we should strive to keep it below 1.5 degrees. It's going to be a heavy lift. There's an assessment going on now to see how we can do that. And so this is what we're trying to achieve. This is what it means. If we're going to do this, the world is going to have to reduce its emissions by something in the range of 50 to 70% by 2050, 50 to 70%. Now, we in the United States contribute much more per capita than the average person in the world, and indeed almost all nations in the world. So we'll need to do a bigger part of that. So the estimate is that we're going to have to reduce our emissions by 80 to 90%, 80 to 90% by 2050. So we're how many years away? It's not many. Sounds like the Bay program when you have these goals and you go whoops and you keep putting it back. But guess what? In this case, we can't delay because the Bay is still restorable if we miss the goal, if we worked hard. This we will overshoot and it'll be too late. So this is what Maryland has done by law. We've set initially a goal of reducing it by 25% by 2020. We're going to actually come, if we don't hit it, we're going to come very close to it. Very positive outcome. And then we've just last year set a new goal of 40% by 2030. So Virginia, come on, do your share. So this is the tide gauge record at Norfolk, at Sewell's Point. You all know the sea level is rising. So the reason we have more frequent recurrent flooding, nuisance flooding, the reason it's higher is because sea level is rising. The main reason now that sea level is rising is because the world is warming. The oceans are expanding, ice that's on land is melting, creating more water in the ocean. That's not the only reason. In this area, because we also have about maybe a 4-inch or so, 4 or 5 inch a year contribution to what we measure at the tide gauge because the land is sinking. All right, so that's been going on a long time, and so that's why the Bay has continued to fill up, and some islands are historically lost. But now we're actually taking it to another level. Now, why should you be concerned about this? Someone was talking before about, well, you know, I've got a home, and I've got the next 20 years, I'll be fine. How many of you have grandchildren? I know I saw this audience that said there's a lot of grandparents out there. I do too. So this is about them. This is about them and their grandchildren, that's why we need to take this seriously. The other thing about sea level is that throughout the Bay, I don't know if you could see these numbers, but that it's rising all over in the Bay, wherever there are tide gauges. But you'll notice down here in the Hampton Roads area, Norfolk and the Chesapeake Bay Bridge Tunnel, you have a higher rate of relative sea level rise. That's because you've got more land sinking. That land sinking, now we understand, is largely as a result of human activities, groundwater withdrawal, returning treated wastewater back to the groundwater to build up. Pulp plants at West Point and Southside Virginia.
So what about the future?
That's something we might
This
actually
is
be able to do something
a way
about.
which the
Managing
best
that.
science has
Tells us we can't give you a direct prediction, but we can give you a probability distribution. And so what this is saying is that if we don't control our emissions toward the end of the century, we'll have probably at least 3 feet of sea level rise that we'll have to contend with. If we do, we will have we'll maybe get away with 2 feet. Now, that doesn't sound like a big difference, but the real story is beyond this, because if we go on this scenario, this just takes off exponentially. So in the next century, will there be a Norfolk? Will there be an inhabited Hampton Roads area? If we're dealing with sea level rise in a century or more than a century from now, that's more like 6 feet and more. Now, you could say, well, that's so far in the future. But, you know, this community was founded, 400 years ago or so. So that's not that long. If you care about a place and you want it preserved, it's important. And so this is important to keep engaged in the planning. The wild card in this is the polar ice sheets. If those big ice sheets in Antarctica and Greenland begin to melt faster, and actually we're seeing signs of that, not that they're melting so much on the surface. You may see some film about that, but they're eroding by warmer ocean waters from the edges. This is a great concern. We could have higher levels if that takes place. Should also just say, in setting Beth up, that sea level rise and warming of the bay isn't the only factor we'll have to deal with the bay. Warming causes more precipitation overall, but it's not uniform. In some areas around the equator, it's going to rain like hell, a lot more. Areas in the north, from us north, it's going to already having more precipitation. Areas in the southwest or in the Mediterranean can become drier. So these are some of the challenges we have to face. Also, we have now clear signs that some of the extreme weather events that we're seeing, this is the Louisiana floods, rainfall floods of last year, and it's very closely tied to the fact that we had super warm Gulf of Mexico water, which are feeding moisture into the atmosphere that's raining back down, causing these extreme weather events. So what is the science telling us? Science is telling us that it's real, it's primarily caused by humans, and it's very dangerous. Sea level rise will accelerate. That curve that we drew a line on, think of that as a bended curve, and the rate of sea level rise is going to accelerate, particularly as the polar ice sheets begin to melt more rapidly. The bay will continue to warm. It's going to hold more water. Sea level rises. The bay gets deeper. That has a lot of effects on water quality and the biology of the bay. It's going to cause more winter and spring runoff, brings more pollutants down to the bay. We should begin to adapt and become resilient to these and other unavoidable climate changes. Some of these, if we took immediate action, we still have to deal with. However, only adaptation only, resilience only, will become a losing proposition later in the century. Without dramatic reductions in global greenhouse gas emissions by mid-century, as I showed you, we will be confronted with conditions in which we cannot effectively adapt to. In other words, we must manage the unavoidable while also avoiding the unmanageable. So any reasonable public policy has to be prepared to do both. So thanks very much.
Thank you, Don. And for the questions, I think everyone has been given a card. If you would write as we go through these talks, you can do it now or wait to the end, write your questions. We'll collect them and select as many as we can to answer. So thanks very much, Don. Now we turn it over to Dr. Beth McGee. Beth?
Let's see if I can remember instructions. There it is. Right here. Okay, so the mouse does show up there. All right, good suggestion. Right, got it. So, well, thanks for having me here. I'm really, Don's a hard act to follow, but you did a great job of teeing me up for what I wanted to talk about, which is sort of more locally what's going on. Don touched on some of these things, but really wanted to emphasize some of the points that Don made and go a little bit deeper. So Don mentioned, one of the things we're going to see is more extreme weather, increased frequency and intensity of storms. So seeing more flooding, you all are well aware of that in this region. But from the Bay's perspective, what that means is more pollutants coming into the Bay. This is showing you a satellite image of the Bay after a storm's gone over. You can see the Potomac River. You can see the northern part of the Bay, which is largely impacted by the Susquehanna River, the largest river feeding the Bay. So that's after a big storm, have a lot of sediment coming into the Bay. And associated with that sediment are other pollutants like nitrogen and phosphorus, those three being the main pollutants we're concerned about into the Chesapeake Bay. So with more storms, more intense storms, more pollution coming into the Bay. As Will mentioned in his introductory comments, a lot of the things of climate change are going to make Bay restoration harder. We have cleanup plans that we're trying to implement, and things like this are going to make our task, unfortunately, a little bit harder than it already is. But on the flip side, and Don mentioned this, is we're going to see perhaps more droughts. And this is actually a map from March of this year in Virginia, with the red areas showing you basins where the stream flow during that time relative to previous years was the lowest 10% that had been on record. So you may see extremes of more rain, but also we're also going to see droughts, and we're already seeing that both in this region as well as across the country and world. Don, same slide that Don had. This is showing you the long-term record from the Virginia Institute of Marine Science as well as the Chesapeake Biological Lab in Maryland, and showing you the terms in water temperature in the Bay over time. As Don mentioned, the overall increase has been somewhere around 3 degrees Fahrenheit since the 1940s. But the question is, so what effect does that have on the critters that live in the Bay? Well, we're already seeing some of those effects. This is showing you an aerial photograph of eelgrass beds. Eelgrass are one of the underwater grasses in the Bay. They're a prime habitat for crabs especially, but also other things like larval fish that live in the grasses for protection from predators. This is actually a grass bed in the lower part of Virginia in 2005 in June. The dark area is the grass bed. So if I can move my little cursor, this is the. Can you see that up there? I know you don't. Oh, you do. Okay, good. So, whoops, that's the grass bed, and you can see here's the same photograph taken in December of 2005. It was in this year. The area's temperatures were really warm. Underwater grasses grow in shallow water. If you've been wading around the Bay, you know the water heats up a lot in shallow water. So in this case, we saw a big eelgrass die-off in 2005. We saw the same thing in 2011, a big die-off. This species, again, is very important ecologically, but it's also at the southern end of its distribution. So it doesn't like these warm waters, and scientists are worried that if we continue, as water temperatures continue to increase, we get warmer summers, that we actually could lose this really ecological critical species here in the Bay. And there are other species that are similarly affected. For example, the soft-shell crab is also at the southern end of its northern distribution. As water warms, we expect that it's going to sort of not migrate north, but its distribution will be limited to more northward. At the same time, we're starting to see species that generally are associated with southern habitats kind of move into this area. So overall, just seeing species shifts depending on how well they're acclimated to warm water or cold water. One of the main impacts, and Don alluded to this, is one of the main problems we're trying to fix in the Bay and its tidal rivers is the dead zone. This is the area that doesn't have enough oxygen to support the things that we like in the Bay, the oysters, the crabs, fish. We have a big area of the Bay that every summer doesn't have enough oxygen. It's the dead zone. Well, from the physics perspective, warm water holds less oxygen. So all things being equal, we're going to have less oxygen in the Bay simply because the Bay is getting warmer. And again, making the challenge of restoring the Bay perhaps more challenging, because that in and of itself is going to mean that the dead zone will be bigger. One of the iconic species of the Bay are striped bass. Striped bass have a temperature sensitivity. They really don't like water that's warmer than about 75 degrees Fahrenheit. I think folks who are fishermen probably know where to find them based on sort of the temperature profile. So in the summer, as the surface of the water starts getting warm, striped bass want to go deep. The water is cooler, deeper, and so they're trying to go deep. But when they go deep, what they find is that big dead zone, because the dead zone tends to be emanating from the bottom of the bay and the bottom of our tidal rivers. So you have low oxygen. So that the striped bass right now is, during the summertime, squeezed in an area where it's too warm at the top, no oxygen at the bottom. And that's only going to get worse when we get even warmer water at the top and less dissolved oxygen at the bottom. The effects, I think we're already seeing this on striped bass. Somewhere around 70% of the adult striped bass in the Chesapeake have a disease called mycobacteriosis, which eventually does kill them. And scientists believe there's a couple factors at play with this disease in the fish. One of them is related to water quality and this fact that they're squeezed. If you're tired and you're hungry and you're squeezed into an area and crowded with all your neighbors, that's when we tend to get sick. Well, the same thing with fish. So Don mentioned this sea level rise, and he also mentioned sort of the double whammy that we have here in the Bay region, which is that sea level is rising because the glaciers are melting, water is warmer, but we also have this land subsidence thing, which is certainly true in this region. And as a result of that, we are losing islands, we're losing marshes. This is showing you a time series from Blackwater National Wildlife Refuge over in Maryland. Is also an area that's susceptible to the land subsidence and also had some issues with an invasive species called nutria. But regardless, what you can see here is that this is happening in Blackwater, but also, frankly, elsewhere and in this region as well. So Don showed a version of this, but on a map, and I'm showing you the same information, but plotted in a bar graph. This is showing you for various places in the Chesapeake. This is Kiptopeke, Gloucester Point, Sewell's Point, Portsmouth, Chesapeake Bay Bridge Tunnel, and the average amount that sea level has risen in the last 30 or 40 years. You can see the big winner, if you will, is the Chesapeake Bay Bridge Tunnel up here, and it's showing you relative to some other places along the East Coast. So a couple things to take home, and again, Don showed the same information, is that that you in this region are about 3 times the global average. This number up here is the global sea level rise average at roughly 0.5 foot per century. We're 3 times that in this region, certain areas, and there is some variability. One of the questions I think that came in when Christy queried folks about what they wanted to hear was how much sort of spatial variability was there in sea level rise, and there does, based on this information, appear to be a little bit even within this region, and certainly up and down the East Coast. And this is showing you, it's a map, if folks are interested in diving into this and sort of looking at where you live and whether you might be susceptible to flooding or what happens if near my house sea level rise is 3 feet, there's a web page here that NOAA has where you can play scenarios where you can simulate various degrees of sea level rise. What's shown here, though, is just the coastal flooding impacts that you're experiencing right now. And again, I know that's no surprise to folks who are in this audience. You're living it every day. I also noticed around the posters that really interesting to see Old Dominion sort of focusing on this as an issue. So these areas in the reds are just runs right now that are experiencing coastal flooding. Again, that probably will only get worse as the seas continue to rise in this region. So how much are they rising? And I think Don made a good point, which is to say it all depends on us. If we don't do anything, we're going to have a worse problem in the future than if we start to do something right now. This is showing you, this is taken from the Virginia Institute of Marine Science webpage. They did a report a couple years ago looking at sea level rise and showing you various scenarios. So there's the high scenario of sea level rise over time, and then there's sort of the midpoint and then the low range. And so you can see, sort of reiterating some numbers that Don mentioned, is that somewhere between 1 to 2 feet in the next 50 years seems to be sort of the midpoint, but it could be worse than that, could be perhaps better than that, but I suspect it's, Don, based on, it's probably going to be not better than the average, but perhaps worse. So I'm an optimist. Will mentioned he was an optimist, and he also touched on a couple of things I'm going to touch on now, which is that there's some good news in that if the things that we do to clean up Virginia's rivers and the Chesapeake Bay actually will, in fact, reduce greenhouse gas emissions, so help us mitigate greenhouse gases, but also increase our adaptation and resiliency to climate change. For example, agricultural practices. These are some of the practices that Virginia and the other Bay states are relying on in order to reduce nitrogen, phosphorus, and sediment loading pollution going into the bay. Forested buffers, so planting trees along streams. No-till farming, that's where you don't till your land, but you allow the residue to remain. Grass buffers, rotational grazing, where you're moving animals around in a paddock as opposed to feeding them grain, and then cover crops, which are planted in the winter. All of these, for one, have the ability to, because they're plants and they're growing, they're sequestering carbon. So they're sequestering CO2, which is a good mitigation strategy. But things like no-till farming and grazing actually make cropland less susceptible to drought. It's building up the soil quality for a farmer, and it's making them, in a dry year, their plants are less susceptible to drought. So again, it's not only good for the environment from the greenhouse gas water quality perspective, but also it's good for the farmer. So there's sort of a win-win-win here. We can also extrapolate that into the urban area. This is a document that we put out this year, I believe, which is looking at what homeowners can do to reduce polluted runoff, so reduce pollution going into the bay, will filter pollution. Also, because a lot of these practices involve vegetation, planting rain gardens with vegetation can also help reduce greenhouse gases. They've also been shown to help reduce flooding, so which is also a good thing, and then reduce what's called the heat island effect, which means having more vegetation, less paved surfaces in urban areas can actually bring the temperature down and make it more pleasant to live here. So again, I'm the eternal optimist. I don't think folks would be in this field if they weren't. And so although we do have a pretty dire situation in front of us, the good news, if you will, is a lot of the things that we're doing to restore the bay, restore our local rivers and streams will actually help in many ways with the fight against climate change. That's what I got.
Holy mackerel. I took that photograph 35 years ago on Carter's Creek, near the Tides Inn, on a very foggy morning as we were sailing out of Carter's Creek. That's great. Thank you. So, you know, when I listen to experts talk about climate change, one thing that strikes me, and certainly with Don and Beth's talk, is extremes, the concept of extremes. Nature craves balance. And with global climate change, it's going to get anything but balance. So now we'll go forward from North Carolina, Dan Berger. Dan. The other Carolina. South Carolina.
Other Carolina.
South Carolina. My mother-in-law is from North Carolina. My father-in-law is from South Carolina. They both would have shot me on that.
No, not at all. Thank you very much for having me to your fair city this evening. I actually spent my formative years on the Chesapeake Bay, just north of Annapolis. So thank you for having me. I'm thrilled to participate in a discussion that might benefit the restoration of the Bay, which is something near and dear to my heart. So, as Will introduced me, I'm Dan Berger from the South Carolina Coastal Zone Management Program. And basically, in a nutshell, what that is, we manage the coastal resources within the 8 coastal counties of South Carolina, from north of Hilton Head, or north of Myrtle Beach, all the way south beyond Hilton Head. But today I'm going to be concentrating. Yes, I'm sorry. Yeah, there we go. All right. But today I'm going to be focusing my talk on some of the highlights about what's happening in the Charleston region. And I'm wearing 2 hats tonight. First, the director of the Coastal Services Division within Ocean and Coastal Resource Management, and secondly, as the chair of the relatively newly formed Charleston Resilience Network. There we are. So for over a decade, the Coastal Management Program has been focusing on coastal hazards, and that's mostly been an academic, data-driven exercise, much, very similar to the technical discussions that we've been having this evening. So what we've been doing lately is transitioning from the analysis into the integration of science into high-quality management decisions and support to our municipal governments within the coastal zone. So we've been focusing on sea level rise and king tides, a term that we, introduced in South Carolina before no one really had anything to call it. It was nuisance flooding, it was tidal flooding, it was just something that happened that nobody really had even, quantified or looked at the social or the economic impact across the region. Storm surge, social vulnerability, looking at the populations who are most acutely impacted by these disruptions to daily life and mobility, and then shoreline change rate. And this has been, particularly important in a lot of our efforts. We've been doing a very comprehensive mapping program of our estuarine environment in 3 time steps, from the 1850s to the 1940s to present day, to look at where the shorelines are changing. Are creeks dilating? Are we seeing extensive erosion in one area and accretion or sand deposition in other areas? And that has, important factors when you start looking at siting of living shorelines and oyster restoration. It can really help determine whether a project is going to be successful or it's going to ultimately fail. As I mentioned, we've gathered a lot of data, and now we're feeding that out to the public, breaking down access to information among the public through GIS-based applications, really trying to demystify some of this to the people who need it most, property owners who don't do this on an everyday basis. We have a living shoreline strategy underway, which I'll talk on in a little bit. And we also have a comprehensive coastal planning program as well, where we assist our municipal governments in long-term beach management, looking at beach renourishment needs and other ways that they can stabilize their dune environment to provide that natural, protective barrier against the Atlantic Ocean. And then finally, well, actually not finally yet, we're also working to align our coastal management program with aspects of the National Flood Insurance Program community rating system. And if you're not familiar with it, but you might already benefit from it. So by a community taking a more proactive approach to flooding and hazard and flood mitigation, they can actually score points, which reduces premiums within that municipal boundary. And then one of the other topics I'll be talking about this evening is the Charleston Resilience Network, of which I'm the founding chair, and that's a recent coalition effort, public-private partnership really, working to ensure that we're all having the same conversation, we're all using the same data, and if a community or a particular profession needs data, they know where to get it. So Charleston, if you've never been, it's generally where the Ashley River to the west of the peninsula and the Cooper River to the east of the peninsula meet to form the Atlantic Ocean. It's a historic, think about that. So it's a historic city, and with that comes historic problems. We have a very antiquated stormwater management infrastructure within the city. The city is spending millions and millions of dollars on it. It's getting better, but it's the hazard is chronic, and the interventions sometimes fall short. Diverse economy. This is very similar to Norfolk, and then I think that's one of the reasons why I'm so happy to be here this evening, because we do have so much to learn from each other. So we also have a massive population increase right now. Our land use patterns are changing very rapidly. We have a lot of density, and we have a lot of new development where we've never had development before. And it's always been business as usual. And we've recently had a couple of events that have tested that thinking. So the city of Charleston, the primary boundary is a peninsula. And as you see by these two maps, we've made some high quality land use decisions generations ago. Much of the peninsula that you see here was built on fill, and we have subsidence issues, which just exacerbates sea level rise problems, whether it's storm surge or it's nuisance flooding, king tide flooding. I won't use the word nuisance in this forum again, I promise. So we've seen these sea level trend lines before, and Charleston is on a very similar trend to this region. We've added about 1 foot of mean sea level in the last 100 years. And, similar around the world, this trend is only looking to increase significantly. So what does sea level rise look like in Charleston? It's not something in the future. It's now. And these pictures, help to bear witness. These photos were taken through our crowdsourcing mobile application. It's called MyCoast, and citizen scientists can help us document king tide flooding in their neighborhood. And just by taking a picture, they're able to upload it, and by the metadata and the photograph and some technical wizardry, we're able to append all of the scientific data. So we're linking the qualitative experience to quantifiable scientific data. So we're able to tell, what the date and time was of the photograph, the sea level or the tide level at the time of that photograph, and then whether or not there were any atmospheric or meteorological conditions that contributed to the flooding at that time. And so this is just a quick recap from, the rather historic floods from 2015. The prediction was that the tide was going to crest in the Sears at 7.1, but in actuality we saw 8.3, which is our coastal flood advisories go up at 7 feet. So at 8.3, the water was well over the Charleston Battery. You also see that the predicted king tide series was expected to last 11 days. It lasted over 21. So that had major impacts, and this was a precipitation event exacerbated by a king tide. This was the passage of Hurricane Joaquin, 500 miles off the coast. This was not surge. If we had surge, this would have been catastrophic. So what do we know about king tides? We know that the frequency and the duration of king tide events exceeds the predictions from NOAA, and that's not a criticism to NOAA. They base their calculations on astronomical information. But what we see is significant contribution from meteorological and atmospheric conditions. So if you have a particularly strong low pressure system, we can see significantly higher tides. The duration, the length of time that mobility is inhibited is increasing as well. And not all areas are affected the same. So that can be based on topography or the infrastructure that's available to move water from one place to another. And this has really significant social, economic, and environmental justice implications as well. So here's just a quick snapshot of the October 2015 flood. We had, massive, 20 to 24 inches of rain within the Charleston region. Extensive flooding. You might have heard about the torrential rains that washed out dozens of dams in the middle part of our state, caused catastrophic loss of property, and also Hurricane Matthew. So before these two events, our benchmark was Hurricane Hugo. And now we have much more recent events that have highlighted just how much Charleston has changed since 1989, with so many more people in so many more vulnerable places. So in 2014, my office and other stakeholders in the region worked with the Department of Homeland Security to do a tabletop exercise. And the real focus was on the vulnerability of critical infrastructure and critical facilities. So our power grid, our evacuation routes, our hospital systems. And they did a really comprehensive climate analysis. So we know that in Charleston we're going to have hot summers. That's nothing new, but we're talking about deadly heat in Charleston. Increased evaporation. We're not going to have as much surface water available. Increasing coastal flooding, which we already knew, and increase in storm surge inundation. And the key findings out of this was that, something needs to be done, and that it can't be done from the top down, that this needs to be locally driven, that any solution is going to be driven by, the organizations in the region that have the capacity to see it through. So we had all these disparate pieces of resilience operating in the region, emergency managers and, coastal zone management. There were communities that were already actively pursuing credits in the National Flood Insurance Program. But we needed to get to this. And so coming out of this conversation, we realized that we had a lot of momentum And we had a lot of, very enthusiastic people, but we were speaking different languages. We were using different sets of information. In one public meeting, you would hear a sea level rise expectation of 2 feet, and the next you'd hear 8 feet. And the public, who we were trying to educate, and key decision makers, they were hearing all kinds of competing information. They didn't know where to go for information. So we decided we needed to become a resource. And first we needed to come to some consensus about how we were going to be delivering this information. So we established the Charleston Resilience Network. And we've only been, it's a voluntary effort. Nobody's getting paid extra to do this, but we know it's the right thing to do. But we've been working as a coalition. It's really a public-private partnership again. We have our owner-operators of critical infrastructure on board. We have Wells Fargo to provide us guidance on how the insurance industry is reacting to a lot of this. We're fortunate to have guidance from the Department of Homeland Security, providing us with that critical infrastructure component, as well as NOAA, which is just a fabulous resource to have right down the street on the old Navy base in Charleston from us. The National Academy of Sciences has also selected Charleston as one of their pilot communities, and they've really been instrumental in being able to provide us access to their Resilient America Roundtable members and providing us a new perspective on how we should be looking at some of these issues, whether it's looking at supply chain vulnerability and resilience with the Port of Charleston and intermodal facilities, down to how should hospitals and hotels be educating the people who are within their buildings should a catastrophic event be predicted. So what is resilience going to look like in Charleston? So we're going to need to improve our stormwater. That's what we call gray infrastructure. We're pouring concrete. We need higher regulatory standards, and that's become a given through the community rating system with higher regulatory standards such as freeboard requirements, which the city of Charleston didn't have one and now is actively pursuing. Well, I think they have a 1-foot freeboard. I think they need to probably go to a 2 or 3 foot freeboard requirement. We're actively pursuing breaking down the barriers to issuing permits to individual property owners for living shorelines, which I'll get into in a moment. Unfortunately, we're going to see continued use of shoreline armoring. In some cases, it's more appealing to independent property owners, even municipalities, to harden the shoreline, to fix it. But we know that when we fix that shoreline, we lose the ecosystem services that the marsh provides in terms of habitat and flood control. But we also need to improve our land use decisions. We need to look at where we have too much density, too little density. Where do we promote development in areas that's in a less vulnerable area, more accessible to an evacuation route? I'm not saying that we've sorted that all out. I'm just saying that's what we need to do. But in any event, we're going to be living with water. We know that. And the more comfortable the residents and the visitors to Charleston become with that notion, the more progress we're going to have. So living shorelines, I know that this is not a new concept. Virginia, in fact, is, I think, ahead of the game, certainly in front of South Carolina in this regard. We currently don't have an individual permit for a living shoreline, and it's a very cumbersome process for an individual property owner to receive a permit for a living shoreline in South Carolina. So what we're doing is working with our National Estuarine Research Reserves and our Department of Natural Resources to establish these site-specific success criteria through these 3 treatments: oyster reefs, vegetative shorelines, and core logs, which are basically coconut fibers. And we're trying to figure out which treatment is going to work best in which area. And so the information that I spoke about earlier about looking at shoreline change rates and fetch and boat wake, all these things factor into whether or not a site is going to be suitable. But ultimately, we want to get a definition for a living shoreline that we can then promote to property owners and governments and say, this is now a feasible, easy, turnkey alternative to shoreline armoring. So these are basically just journal articles that say we're not making this up. It's been studied. They work. They have significant resilience benefits. There are studies coming out of North Carolina that living shorelines outperformed bulkheads well, Category 1 hurricanes, but we can surmise, that that would hold true in other situations. But they're also adaptable. As the shoreline changes, you can change your living shoreline. Once you fix that line with a hard erosion control structure, the ecosystem service is lost. So quickly, other good news from Charleston. The city has a sea level rise strategy. It was adopted by council. They've adopted a 2.5-foot sea level rise in the next 50 years. And that was based on U.S. Army Corps and NOAA extrapolation of the data and finding where science can meet policy comfortably to be adopted and then implemented. So it's not, it's scientifically valid, but it's also politically palatable. And so the city now has a resilience position. It's not a chief resilience officer position. It's additional duties and responsibilities for their emergency manager, but he's more than up to the job. And he's actively working on ongoing integration of projects and programs across the city and really coming to the Charleston Resilience Network for information and support for what he sees as opportunities and what needs to be done in the city. So in Church Creek, this is very recent news. We've actually, the city has actually put in place a building moratorium, and this was to the excitement and relief of both this council representative of this area as well as the property owners, because something needs to be done. It has seen significant flooding in recent years, multiple repetitive lost properties, and this is not with a hurricane. This is not with a tropical storm. This is environmental change that is leading to chronic flooding conditions for these people. So the moratorium's on for the next 9 months while they sort out a number of studies, but I'll keep you updated on this one. This is going to be very interesting because I think that this is going to be the trigger for the city to adopt some significantly higher regulatory standards. We're also working with the nonprofit community in the Upper Peninsula of Charleston. There's a great organization called Enough Pie, and they're really a social and environmental justice organization, whose credo is that there's enough pie in Charleston for all of us, and no one, regardless of where you live, no one should be treated unequally. So we're doing a month-long community engagement with them and using art to communicate science and to raise awareness and to give people not just information, but a pathway to better their communities and to become more involved and to help mitigate some of these flooding impacts that we see. So the picture I'm showing you here is a subsidized public housing unit in downtown Charleston on the peninsula, right next to the highway, so super high visibility. So it's about 100 feet tall and about 35 feet wide between there. And what we're doing is to kick off this event is dropping these great tapestry banners from a local artist named Mary Edna Frazier, who let us use her artwork. And kind of paraphrasing Voltaire, the poster reads, "We argue, nature acts." So the sooner we get our acts together and come to consensus that something needs to be done, the better off we're going to be. I have 1 minute, so touch on the community rating system. I'll go right by that one. So our challenges really are that changes in policy are going to lag the impacts. People will continue to be impacted through these chronic king tides. And, every once in a while we'll have a hurricane, we'll have something happen offshore, and it's just going to get worse. Sea level rise is going to exacerbate these king tides. Precipitation, which we're seeing changes in our precipitation patterns, we get an awful lot in a very short amount of time. Infrastructure is very expensive. The city and the county and the entire coastal region is going to have to look at how are we going to fund these things. It's great to have a plan. It's great to map out infrastructure capacities, but we need to talk about who's going to pay for it and when. And then finally, Charleston is a fabulous place to live and visit, and it's driving a tremendous amount of growth. And that growth continues to be placed in highly vulnerable areas. Oftentimes we have wetlands that are being filled, and those wetlands are not just muddy pits that endangered salamanders crawl around. They provide an essential ecosystem service in flood mitigation. Unfortunately, in South Carolina, we do not have a comprehensive wetland management regulation. So as long as there's mitigation to wetland fill in the coastal zone, it continues to happen. So we're going to keep fostering these relationships. We're going to refine these models. We're going to get the information to the people who need to get it. But most importantly, and this is interesting work that's being done right now by the Urban Land Institute, is we also need to calculate the cost of doing nothing, and it's significant. It is very, very significant. So if we just continue with our current development practices, our current building practices, we're really going to be putting ourselves long-term at a significant social, environmental, and economic disadvantage. So thank you very much. I really appreciate being here.
South Carolina is proud. North Carolina is jealous. Thank you very much, Dan. And now from the Netherlands, Dale Morris. Dale.
Well, good evening, everyone. Thank you. I have a difficult job. I almost got up and walked away when Dawn said adaptation is foolish in the long term, and we need to mitigate first, because my story is pretty much about adaptation and adaptation in cities. So we're hearing a lot about ecosystems, marshes, coastlines, fish, but we're not talking about people. And I think perhaps that's why Christy pulled me into this, is because we want to talk about how people interact with these wonderful coastlines we all like to live upon. And Christy asked me to talk about the Dutch dialogues in the context of inspiration and as a catalyst for moving things forward, and we've done that. So I'm going to start with a few scary slides and then move into the Dutch dialogues and then show you some solutions. This is common knowledge to all you folks, but a lot of people live in some really nice, dangerous areas around the world, and a lot of GDP in the U.S., but around the world is produced in these wonderful, dangerous areas that we call coastal cities and coastlines. So we don't do something, we're going to kill a lot of people, and we're going to destroy a lot of economic capital. And if you're anything about human progress, that's probably not what you want to. That's probably not what we want to do. So this is costly. Doing nothing, the opportunity cost of doing nothing is substantial. You can look at what's happening. $1 billion a year. The $1 billion a year disasters are occurring 3 times more. $34 billion a year is the average cost to the federal government of these natural disasters. Katrina cost $150 billion a year. Sandy, $60 billion. Ike, $40 billion. Isaac, $2.9. Houston's had 2 300-year storms in the last 3 years, which cost them $4 billion. Matthew and the Baton Rouge flooding just last year. These are substantial costs, and if we don't do anything, we're going to pay for it. We're going to pay individually or collectively. So it's important to deal with that, just accept that. The cost of doing nothing is too high. And it's not going to stop. Here's another of these scary graphs. This is from Munich Re, the big reinsurance industry. You see this trend. Look at the blue and the green bars in this graph. It's increasing. Those are water-related flooding or rainfall event losses. It's not going to stop. We just add this on top of the other 2 graphs that Dawn and Beth showed. It's not going to stop, so we need to do something. So the Dutch have a very existential problem with their water because they live, 60% of the country is at or below sea level, and about 70% of the people live in, and the 70% of GDP is produced in that area. But they feel pretty safe because they've made investments. They've had to. And they also have the public will to adapt. So they're willing to spend the tax dollars. They're willing to trust the government with private sector, with researchers, and with universities to develop solutions that work and create value. It's a pretty wealthy country. GDP per capita is slightly less than the U.S., but if you've been there, it's pretty nice. And their sea level rise predictions are 8 inches by 2050, almost a foot, almost a yard, or almost a meter of sea level rise by the end of the century. It's fairly substantial. So what are the Dutch doing? Well, they're adapting. And the fact of the matter is because they spent so much money over so many years adapting, they're fairly well protected. They're fairly confident that they don't have to do a whole lot but add to what they have in targeted tactical ways between now and 2050 or 2060. So they're ahead of the curve in some ways. And so what I do in my job at the embassy is we try to bring that Dutch expertise, this Dutch approach, to the U.S. to help certain cities. We've done Dutch dialogues. This is a process I'll tell you about. We've done these Dutch dialogues in a number of cities, primarily New Orleans. We did 3 of them there, which produced some, was a catalyst for change there. We did one in Norfolk, in the Hampton Roads region a couple of years ago. We've done in Los Angeles and St. Louis. And what we do through this process, we just try to get all of the heads, all of the really smart people from the region, put them together out of their silos, because that's important, just take people out of their silos. Put them in a room with some smart Dutch people that we've sort of selected that we think can help prod them or help them think along. Give them a challenge to solve, a challenge that the community wants to be solved, the challenge that the community identifies as being a problem. And then we try to, through 5 days of real work, and Ben and Whitney from the HRPDC are back here, and about 4 months of good preparation with a lot of data and maps and a lot of asks from us, we produce something that the politicians get and they have to respond to. And all that does is it catalyzes people to think differently in better ways. So again, we're trying to look at multiple benefit solutions. It's not just flood risk mitigation. It isn't just stopping nuisance flooding or recurrent flooding, or Miami they call it sunny day flooding. It's dealing with a bunch of different things. You get all the noses pointed in the same direction. And again, we've been successful. I'm going to walk you through some of the process of the current mini Dutch dialogue that's underway in Hampton. But this was the map that we started with for Hampton Roads. When the Dutch went to New Orleans, they heard it was a water city, but in fact, there's no water in the city of New Orleans. It's all hidden. And when we were exploring Dutch dialogues down here, we looked at this and said, this is probably the best map to show people what they're facing. It's not a map that you normally see. It's not an orientation you see. But this is it. The rivers, the estuary, the bay, and the ocean all coming together. And that little land around there, that's pretty important too. But this is a water place, and you need to just understand that. That's your risk and that's your benefit. And in the Dutch dialogues, we look at a region. We look at scales, both in temporal scales as well as physical scales. And we try to find problems or areas with problems that are prototypical for the rest of the region. And so in the Dutch dialogues for Norfolk, for Tidewater, we chose Chesterfield Heights, an area sort of east of downtown Norfolk, and Newmarket Creek up in Hampton, and the region. And we look in the so moving now to this Dutch dialogue that's going on here with Hampton, we look at a number of things just from water. So what are these various impacts of water going on? Groundwater surge, rising tides, rising mean sea level, surface runoff with all this extra precipitation, the storm clouds that we get, and then overall increased precipitation, and then the capacity of the drainage system to deal with that. As you know, most coastal cities do not have sufficient drainage capacity. We look at the risks to the region. This is economic risk. This is national security risk. This is risk to homeowners. This is risk to business. This is risk to the United States economy, clearly Virginia's economy. So we look at all this infrastructure and what's at risk and try to understand that, because that can help you identify partners. And people can provide you with funding as well as solutions. We looked at the storm tides in this region as well as Boston and New York, Long Island Sound. You get this thing called stacking tides here. So you have them you had them down there in Charleston too. But your tides don't come and go. With a storm, they hang around and cause a lot of damage and repeat damage. And you can see, in fact, your storm history over the last 20 years, you have most of your big storms have occurred, they're occurring more frequency. So you've got a problem. And helping people understand that, the naysayers or the people who are skeptical with this kind of data is very important. You have to put this in front of them and say, okay, we need to grapple with this. And over in Hampton, so we always look at the current FEMA flood maps in the U.S. or the flood risks in the U.S. So what's happening right now? What does the government or what does the experts tell you? What do they say? Okay, so this is the flood risk in the flood risk zones in Hampton, and this is the shoreline condition in Hampton. So you get your starting point, and we'll look back too, 20, 30, 40, 50 years, so we can see the change from then until now. And we try to understand, so what's sea level rise, relative sea level rise, so both subsidence and sea level rise, measured sea level rise on top of that, so you can understand that, and you get a sense, so what's our planning horizon? What are we trying to solve over what period of time? It's important to understand that if you're looking for a 50-year or 70-year road project that you're trying to add some multiple benefit in for flood protection, you need to understand what you're planning for. So it's important to understand what we think the future is going to look like with water. And then we look forward. So what does 2 feet of sea level rise in 2050 mean to Hampton? You can probably see this very briefly. There are a few, you can't see the red, but there are some buildings at risks in these areas. But if you go forward, you can start to see more and more red coming into play. So you have 1,500 buildings at risk with 3 feet. With 5 feet, 7,200 buildings at risk. So that's what Dawn is telling us. We've got some real problems. But you need to understand this so we can then focus our investment. We can focus our efforts to think of retreat if we need to think of retreat, or think of hardening structures for facilities or things that cannot be moved. These are trade-offs we're going to have to make, and we just need to sort of put them out there and clarify them. We look at the foundation types. So so what could you do with homes in these areas? Which ones are at risk? What are the solutions that you can provide to a homeowner, to a block, to a community, to the city? We look at the drainage system and how that's interacting with sea level rise. Sea level rise, you get this problem in Miami. It's called sunny day flooding. Most of their surface drainage system flows backwards into Biscayne Bay. Sea level rise comes up with a storm or a passing pressure system. The water can't discharge. It's bright and sunny, hasn't rained for 3 days, and all of a sudden water's coming up in the street. That's because these drainage systems are now below, the tail of the drainage system is below the level of the water. We look at groundwater depths, because that's very important to understand, and then we try to figure out what's going on. So this is not a marsh. This is a poor drainage. These are poor soils around a person's house. This situation is probably not going to get better. So people need to understand that so they can make investments. They can make choices. This is what a Dutch Dialogues tries to tease out. We look at, very importantly in the Dutch Dialogues, we don't just look at homeowners. We look at people. So what is the social vulnerability index in some of these cities? It is a common fact of knowledge that maybe not in Norfolk, or maybe not in this area predominantly, but in a lot of other places, the poorest, most vulnerable people live in the most risky places. So they're bearing a heavy burden. We try to understand that so we can then tease out solutions. What should we do about that? We're not going to propose major social cost programs on people, but we need to understand this so solutions can be developed by the local community. And again, we do this in an interactive way with biologists and engineers and hydrologists and city planners and politicians and interested stakeholder groups and environmental groups, so they're all talking and understanding, developing a common knowledge for the problem. We look at the historical development because our forefathers, the people that came before us, they did some dumb things, but they did some really, really smart things. And we need to understand what they were. Why did they develop where they did? So we need to understand that. And so that's a Dutch Dialogues process. They're very successful. We don't undertake them lightly. It takes probably 4 months of preparation. We don't do it unless we think we can have an impact by combining the Dutch approach to living with water, and it's a newer approach, and the local stakeholders and the local challenge. So that's a Dutch Dialogues process. Ron is here. Ben and Whitney are here. Some of you participated with us. Michelle's here. So we think it's been successful. The most successful one, I would say, to date, given what we've been able to put in the ground, is the Dutch Dialogues in New Orleans. Started in 2008, 2010, 2 times. Led to the creation of the Urban Water Plan for New Orleans, was the first of its kind in the United States. It's won many, many, many awards by planners and urban designers and hydrologists. It's very important. It was incorporated, the Urban Water Plan was incorporated in 2015 into the first resilience plan for a city of the United States, and that's the City of New Orleans Resilience Plan. And now they're doing things with it, and I'm going to show you what that is. New Orleans, as you know, was a city that didn't have any water in it when there wasn't a hurricane nearby. Katrina showed you 80% of the city could fill up with water. You can see a different imagination of New Orleans' future here. It needs to become greener, and it needs to become bluer to deal with its various flood risks. Their coastal flood risks, their precipitation flood risks, their groundwater flood risks. And they need to understand that. And so this plan, this drawing, sort of indicates where they're going. This was the end drawing for the Dutch dialogues for the project area for Norfolk. So here you see Chesterfield Heights and the area between Chesterfield Heights, Ohio Creek, Newton Creek, and the ballpark in downtown Norfolk. It's a smaller area, but you get a sense that we are not holding water out of the city. We are trying to let water in and out so it does better things for the city. There's water quality improvements here. There's flood protection improvements here. There's ecosystem services improvements here. There's economic redevelopment here. So this is an idea. And fortunately, we can say that the city of Norfolk was a successful applicant with some of this information to the National Disaster Resilience Competition. And they have $121 million to implement some of this stuff. And they're struggling with that right now. They're implementing, but it's still a struggle. But we wish them every success. This is Hampton. This is New Market Creek up in Hampton. This is an imagination of that watershed, which is so important to the city of Hampton and homeowners there. It's a wasted asset. It's a creek that could be so much more. It can provide water storage. It can provide backyard amenity for people. It can be done in a lot of different ways. And right now it's a wasted asset, we think. And we see opportunities here. I want to talk about this project in the Netherlands. I got the 5-minute warning. A couple projects in the Netherlands. These are related to things that be done here. This is a little town on the Dutch coast called Katwijk. The red line in the middle was the sort of the old protection line. So the coastal dune is the primary protection, but in this city, it went back into the city. Dutch government didn't like it because it's putting people at a lot of risk if a North Sea storm comes along. So the Dutch government said, you know what? You need to raise the coastal dune in front of the city by 10 feet, and you need to widen the beach. Now, all the homeowners there and the retail and beachfront is like, you can't do that because you're going to cut off our development. You're going to cut off our money. You're going to cut off our view. Please don't. So they worked with some really smart Dutch engineers and actually a Spanish designer, and they came with this idea, so let's put a dike in the dune. The dike is just a piece of concrete or some sort of reinforced dirt that will hold back, withstand the forces of coastal surge. So they put a dike in the dune, and they put a parking lot behind it. Now, there are 660 parking spaces that are beachfront, so access is better. The dune didn't have to be raised. It had to be cut open and then put back. But now they're charging the German tourists 10 or 20 euros a day to pay for the structure. There it is. Look at the bottom, these two bottom pictures. The parking garage is underneath that thing. So pretty nice, right? Scheveningen, it's sort of Atlantic City. They needed to increase the protection there. And the business community and the people who use that piece say, don't screw it up. We like as it is, improve it. And the Dutch government said, we're just going to put more sand on the beachfront. The people said, no, we need to do something different. So here again, they lifted the beachfront in a very short period of time. For 9 months, they put a dike underneath it, and then they added some very important structures to this to make it safe, but also to make it more attractive. So now the retail value and the economic activity related to this beachfront is higher than it was. So there you can do these things in smart ways. So sediment, putting sand on your beachfront. You can do this in different ways. So this here was a big pilot project, an experiment. The sand engine. 21 million cubic meters of sand, and they Dutch got it for $4 a cubic meter. You engineers in the room will just know that's really cheap. For a 20-mile stretch of beach, and they put the big pile of sand there in November 2011. And now they're just going to let Mother Nature distribute the sand over 20 years. It's a science project, but they're willing to experiment to see this. And what happens is the dredgers were contracted for 3 months for this stretch of beach, so you're now reducing the costs and you're letting Mother Nature do the work. And here it is in 2014. You can see this thing dispersing. Here it is in 2016. You can see the beach getting better, the dunes getting better because this sand is blowing back and forth, and the foreshore is much safer now. It's going to stand a better surge. Coastal restoration, I'll skip that. Gentilly, I'll skip that. This is a project, I'm short on time. This is just a really cool project. 1 minute, okay, good. This is a really cool project. It was a convent, 25-acre piece of property. The nuns got flooded in Katrina. They left. They wanted to come back 6 months later. Lightning hit their convent and burned it down to the ground. So they're wondering what to do. They're living in Baton Rouge. They heard what we were doing with the Dutch dialogues, and they told the city, we will give you this piece of property if you use it for that thing that the Dutch dialogues folks are talking about. So right now, this is a neighborhood in Gentilly, and they are going to turn this into an urban park with some amenity for job training and maybe a water center, but it's going to store the water from the neighborhood, so you don't have to increase the pumping system, and it's going to infiltrate water back into the groundwater system, so you reduce subsidence. This area was subsiding pretty quickly. And here you can see a design of what's going to happen with different kinds of rainfall. Here's the graph that shows you this thing is really effective in dealing with stormwater in these neighborhoods. And it's part of a larger comprehensive plan, and they too got $141 million to start implementing this broader plan. You can store water in different ways, in parks and high grounds. You can store water. You can make your drainage infrastructure at New Market Creek look something very pretty. It doesn't have to be ugly. This is a drain in the Netherlands, but it's not too bad. You can use green infrastructure. All these things they add up, and they make a huge difference. And then these are two final projects, and then I really am done, sorry. These are two final projects. So here's a parking garage, this thing on the left with the stripes on it and the trees in the front of it. That's a parking garage that was built just recently to redevelop an area called Zoho. There was a hospital, museums, whatever. They needed parking in there. So they told the developer and all the areas, you need to store all of your rainwater for the 100-year storm and less in that area. It's a big assignment because they didn't want to increase the pumping system. So they did. So they have all this water on the front. This is the entrance. So this here is looking right this way. So there's water up there on the top. And in this area, in this garage, they made the contractor put a water storage chamber in. So when the water on the top gets filled up, it goes into this water storage chamber. It sits there until the storm passes, and then they just pump it back into the normal drainage system. So now the people parking in this garage for this redevelopment are paying for this flood infrastructure. Pretty smart. And here's the final project. This is a water square. These are popping up all over the Netherlands. This was an area with a school nearby, that brown building in the bottom right. That was a school. Kids didn't have any place to play. It's a constrained urban area, sort of lower middle class. They needed something. So they gave them a basketball court, and when it rains, the water flows into there. So they don't swim in it. They're just told to leave it alone. That stores the rainwater. Excuse me. Talking too fast. Anyway, that stores the rainwater, and we're speaking of water. Anyway, so you get the sense. What I'm trying to tell you is this kind of adaptation, although Don tells us it may not be wise in the long term or smart in the long term, we have to find ways to show people how to live with water. And so these Dutch dialogues and this Dutch-American collaboration can do that. Thank you.
Before I ask you to give all of our four speakers another round of applause, I just want to give thanks to all of you. You can really tell when you're up here when audiences are interested and attentive and engaged, and you were. So give yourselves a hand and give our four speakers a hand. Thank you. Now, while I'm waiting for some of the questions that hopefully you have been filling out cards on, let me give a little Bay commercial. When you came in, you got other cards. These 4 postcards we urge you to use to let your elected officials know that the proposal coming out of OMB to cut the Chesapeake Bay funding from $73 million annually for many, many years to 0 is unacceptable. And I think you'll find that our legislative leaders here in Virginia are sympathetic. but the more communication they get from their constituents, the stronger their resolve will be in Congress to put that money back into the budget. So please, if you're willing, don't ignore our request to use these cards to let them know. Now, some questions. I'm going to come back to that. Where on earth will the effects of climate change be most significant, in addition to Hampton Roads? I added that last part myself. And you can answer the question from your places. These mics are on, or you can come to the podium. Who'd like to try that? Don?
Well, I think on one hand, the amount of warming is going to be greater and is already being greater in the polar regions. However, almost any place we look on Earth, we see really troubling signs.
We might have to bring people up.
Okay.
It's on.
So you see troubling signs. So one of the things that's just galvanized attention in the last couple of years is these mass mortalities of coral reefs that you've seen, the whitening effect on the Great Barrier Reef. Small increases in temperature have the potential of wiping out this wonderful, diverse ecosystem that is irreplaceable. So, anywhere you look, there are those threats. And while I have the microphone, I really enjoyed both Dale and Dan's presentations. And, of course, I hear Beth, and we talk all the time, so she was great, too. But just to be clear, I'm not suggesting that we have to do mitigation, that is, reducing emissions first before adaptation. We have to do adaptation now. But if we only do adaptation and don't slow the rate of warming, we're going to run out of room to adapt, and therefore, we cannot put it off. It's not something that is second. Both of them have to move forward at the same time.
Thank you, Don. Here is a question for someone, maybe someone from the audience. Where was it? Asking, is Hampton Roads, well, first of all, will the slides tonight be made available on the net? If so, where? cbf.org/Blue Planet. Now, I can't find this, but the question was, is there going to be any significant construction in Hampton Roads to adapt to, mitigate climate change? Anybody from the audience? Christy? We keep mentioning Christy Everett. For those of you who don't know Christy Everett is our dynamic executive director here in Hampton Roads. Christy.
The question was, is there a construction project in Hampton Roads related to responding to adaptation for climate change? I would say I'm not the best person to speak to this, but the City of Norfolk, the National Disaster Resilience Competition project at Chesterfield Heights, $121 million project, I think would be the largest project. Dale, if you want to...
Yeah, so there's... So the Norfolk work, there are some other smaller projects we know going on. There are ongoing projects that the Corps of Engineers is always doing. We need to applaud them. I saw Colonel Kelly here a little bit ago. I don't know if he's still in the room, but he was here. Anyway, so there are always little projects going on. Ben and Whitney from the HRPDC, they are working to get more funding. So there's activity. But I will say this, the activity, and this applies in most places in the United States, there's a lot of talk. Not much is being done to mitigate this risk. And that's some of my last slide. You can read it. There are a lot of reasons why we are not getting stuff done in the United States. I'm not Dutch, I'm an American, and I see all of these people at risk, and it scares me.
Masquerading as a Netherlander. Okay, two questions for Dan. I'll give them both to you. First, were there any fatalities from Jochen? Is that how it's pronounced? and Matthew in South Carolina? And second, will Charleston consider relocation as a measure of resilience?
Great questions. Thank you. Is this one on? All right. No, to the best of my knowledge, in both Joaquin and Matthew, there were no flood-related fatalities. So that's brilliant news. There were very good evacuation plans in place for both elderly and infirm populations. Hospitals got people out to higher ground if necessary. And a lesson learned from Hurricane Hugo is making sure that your shelter is outside of the floodplain. Yeah, hot tip there. So I'm sorry. So relocation. Relocation is a very sensitive topic in South Carolina. There, obviously, anyone can voluntarily relocate their home should they deem that the necessary intervention. In South Carolina, we have a state policy of retreat from our beachfront shoreline, but that policy has largely been defanged in subsequent revisions to our regulations. So a policy of retreat is very difficult to implement on a broad scale. We do find opportunities to work with property owners to move their houses back and allow natural dune accretion to occur where their home may have been preventing it when the shoreline has eroded back to where their property had been originally platted. But it's a difficult conversation. Oftentimes, particularly along the beachfront, there just simply isn't a place to move a house back or out of the way, and people hold on to their property, clutching with two hands.
Thank you, Dan. There were a number of questions along the lines of what is the best thing a homeowner can do to address climate change? Beth?
Hello. Okay, it's on now. Good. I'm going to cheat and give 3 answers. The first is contact your elected officials and know that you care about climate change, and whether it's at the state, local, or federal level, because I think lots going on here locally, and you're hearing from your local officials that you care about is really important. The second is probably more what the person who asked it was intending, which is around energy efficiency. Heating and cooling our homes is probably one of the most greenhouse gas emitting things that we do, and so things like weatherproofing your home, making sure your windows are insulated. There's a lot of state and federal programs that will provide some money in response to doing things that are make your home more energy efficient. And the last thing I'll say on the flip side of that, which is to plant trees. So vegetation soaking up CO2.
Also, solar is becoming a great option, a cost-effective option for homeowners where it's appropriate, where you have the right conditions and able to do it.
Solar. Keep your microphone on, Don. 2 questions for you. One, how is Maryland going to achieve its CO2 reduction goals? And secondly, even if we reduce man-made emissions by 80 or 90% over the next 30 to 40 years, won't warming continue due to high concentrations of greenhouse gases, increased release of methane, et cetera, et cetera?
Right. Maryland has enacted a number of, in addition to the law that sets the goal, a number of policies set in law. One of them is that we're a member with the other northeastern states of the Regional Greenhouse Gas Initiative, which is a cap-and-trade system for our public power generation utilities. So they have to be able to show a net reduction of their emissions. We have California car standards. We have other kinds of things that are helping assistance to lower-income folks so that they can put their homes in a better energy efficient condition. A whole number of options like that. But that's enough to get us in the first level of reductions. In the long run, we're going to need federal policies that will take the whole nation to this level as well. So the other question is, will the Earth continue to warm? Well, that lower scenario, that's designed to, if we get to 90%, 80 or 90% by 2050, That's not over. It means before the end of the century, we have to get to zero net greenhouse gas emissions, which means that we're going to have carbon sequestration efforts, either sequestration in the earth or through biomass. But it also, and if we are able to do that as the whole world, we can stabilize the temperature so that it won't warm and it will slowly decline in the next century. That's the temperature. For sea level, on the other hand, I'm afraid we've launched a beast, because even if we do that 2 degrees C goal, sea level is going to continue to rise into the future. Much more, much faster if we don't reduce emissions. But even now, we've committed ourselves to accelerating long-term sea level rise for many centuries into the future.
Okay, here's one I'm going to take in where I think close. Christy, wrapping up? You're doing all right? A few more minutes? So this question is, I'm opposed to oil drilling off Virginia Beach. Given the climate change impact of offshore oil drilling, can we tell what the effect on sea level rise would be? And I'll answer that and say civilization as we understand it today will cease. Anybody want to pick that up with a more learned response? Impact of oil drilling?
I think, the whole debate about oil and gas development off our shores is, and I worked on the Gulf spill, worked in the Gulf of Mexico, from that region, and realized the tremendous burden that region has suffered as a result of providing energy for the nation. So I realized that it's necessary to continue that for a while. But to open up, if we're going to have to go to 80% reduction, 90% reduction, why are we opening up new areas of fossil fuels in risky conditions? It just doesn't make any sense.
Okay, last one, and then we're going to ask Dr. Michelle Covey to close this out. This is for Dale, are Dutch citizens given tax breaks or incentives to curb stormwater runoff and or mitigate flooding?
Yes, they will get. So the national flood protection is paid through what's called general revenue and normal taxes. So there's no benefit when the homeowner takes no net tax reduction there. What they do get is when they put a rain barrel in, or they put some plantings in, or they do things on their own property, they will get a reduction of the fee that they pay to the local water authority. So it's a local tax, and the tax reduction is based upon their load, fictitious load on the system that's well calculated, and then what they're doing, their percentage of the reduction of that load on that system. So yes.
Thank you all very much. Dr. Michelle Covey, Virginia Sea Grant, and Old Dominion University. Michelle.
So thank you. So just on behalf of ODU and the Sea Grant program, and also on behalf, I would like to thank, and Will already thanked the audience, but again, thank you so much for your kind attention. Thank you so much to our great panel. They did a wonderful job. And also, I'd like to thank the organizers, Christy Everett and her team at CBF, and also Christine LaPuma and the team here at ODU for helping to put this whole program together. I think they did a tremendous job. Thanks a lot. And if you have a little bit of time to look at the posters, take some time to look at those, but have a good evening.
Thank you.
Are you staying over?